Here's section 4.4, triangle congruence, SSS, and SAS. So here's the objective. Prove triangles are congruent by using the SSS stands for side, 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 and SAS stands for side, angle, side. And these are going to be two shortcuts that we're going to be able to use to show that two triangles, or to prove that two triangles are congruent. And this is the vocabulary: included angle. Let's go to the first shortcut, or postulate 441, or side, 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 congruence postulate. I'll read this to you. It says if three sides of one triangle are congruent to three sides of another triangle, so this is what we have here in this illustration. Three sides of one triangle are congruent to three sides of another triangle. What is the conclusion? Then the two triangles must be congruent. And again, this is the first shortcut that you're going to be able to use to show that two triangles are congruent. Let's go to the next slide. It says this is going to define what you see here. It says an included angle is an angle formed by two adjacent sides of a polygon. So basically, these are your two adjacent sides, BA and BC, which means that this angle here, the one that is you see highlighted in red, is the included angle. And that's what I just went over right now. Let me move on to the next slide. Here's the next shortcut, postulate 442, or side angle side congruence postulate. Let me read this to you. It says if two sides in the included angle of one triangle, here are the two sides, here's the included angle, are congruent to two sides and the included angle of another triangle, here's the second part, two sides and the included angle, then the two triangles are congruent. Again, this is the second shortcut that you will be able to use to show or to prove the two triangles are congruent. Let's go to the next slide. It says show that the triangles are congruent for the given value of the variable, and we want to show that these two triangles that you see here are congruent, and this is the x value. So what we're going to do is we're going to plug in the x value first into PQ. Once I do that, I get PQ is equal to 7. So PQ is 7, and the other side that is also 7 is MN. So these two sides, since they're equal, they must be congruent by definition of congruence. Next one, QR. X is 5, so this is 5. If this is 5, this has to be congruent to this other side, and no. Since they're equal, they must be congruent by definition of congruence. That's why we see this here. Next, the last one is to plug in x into PR. PR, once you substitute, you get 6. So this side must be congruent to this side, or equal. And by definition, since they're equal, they must be congruent. So what allows me to say that these two triangles are congruent? They are congruent by side, side, side shortcut, or side, side, side postulate. Let's move on to number 2. So very similar directions as number 1. We want to show that these two triangles are congruent with the given value. And here are the two triangles. STU congruent to VWX when y is equal to 4. So first, we plug in y into ST, which is here. Once I do that, I notice that this is equal to 11. Since this is 11, ST must be equal to VW. And since they're equal, by definition of congruence, they are congruent. Next, I'm going to plug in y into TU. So once I do that, I get 7. So I know that TU is equal to WX. Since they're equal, they are congruent. And you know why. Then the last part is basically to plug in y into this angle here, T. Once I do that, I get 92. So now that I know that this is 92 and this is 92, change the color here, I know that this angle is congruent to this angle. So why are these two triangles congruent? they're congruent by, excuse me, so angle T is congruent to angle W. Why are these two triangles congruent? They're congruent by side angle side. Let's move on. This is the shortcut again. Let's move on to number 3. This one's just a little bit different. It says use side angle side to explain why triangle XWZ is congruent to VWZ. It's sort of like a proof, but you're going to explain this using some sort of paragraph format. So here we go. So this is how we're going to start out. We're going to use the given information, and notice by looking at the problem, I know that by the tick marks, I have some sides that are congruent. So since that's given, we can say that it is given that XZ is congruent to VZ, XZ congruent to VZ, and the same manner, these two sides are congruent. From here, I need to use something that I know to show that these two triangles are congruent. This angle and this angle. And we can say this by the vertical angles theorem. That's why they're congruent. Angle XZY is congruent to angle VZW. So from here, we're pretty much done. So we just need to explain why these two triangles are congruent. We can say so. Triangle XYC is congruent to triangle VWZ by one of the shortcuts that you saw earlier, which is side angle side. Let's go to number 4. So in the same manner, same directions, we're going to explain why these two triangles are congruent using side angle side. So looking at the picture, I know that I have some given information that is congruent equal. So I write that down. It is given that BA is congruent to BD, and also that angle ABC is congruent to angle DBC. From here, I need to use side angle side. This is my side angle. If I'm using side angle side, this must be the other adjacent side to this side, because this is the angle that is given to me that is these two angles are congruent. So then I'm going to have to say that this side is congruent to itself by the reflexive property of congruence. And then from here, what allows me to say that these two triangles, the one on top and the one on the bottom, are congruent. The shortcut that we're going to use is side angle side. Let's go to the next slide. So here's number 5, says use side, side, side to explain why these two triangles are congruent, ABC and CDA. So just by looking at the given information, I know that these two sides are congruent, AD and BC. In the same manner, CD and AB. So I'm going to write that on my given in just a little bit. In addition to that, since I'm using side, 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 I know that this side, AC, is congruent to itself by the reflexive property. So if I was to write an explanation why these two triangles are congruent, this is what it should look like. You can pause to read this, but you should be able to follow. Let's move on to number 6. And it says this is a 2-column proof. I know. You're welcome. So you're given that BC is parallel to AD. That's what you see here. And also that this side is congruent to this side. And we want to show that triangle ABD is congruent to triangle CDB. And this is what we're going to do. I want you to attempt this problem, and then we'll go over the answer. We'll check your answer in class. Let's go to number 7. So this is the given. Ray QP bisects the angle RQS. Here's your RQS, so it bisects. And the other piece of information is that QR is congruent to QS. And we want to prove that these two triangles, the one on the left, is congruent to the triangle in the right-hand side. And just like number 6, I want you to try this, and we'll go over the answer. We'll check the answer in class. This concludes the video.